startups typically can fall in love with the technology and forget to think about how do we now bring this to market and how do we scale this to meet customers' expectations. And, hard to put a metric behind how frequently that happens, but it does happen, particularly when you have the founders or the owners still involved in technology development. That's their speciality. And it takes a different skill set to think about building the commercial facing part of the organization and the manufacturing part of the organization.
Welcome to the Lab to Market Leadership Podcast. Too many advanced science and engineering companies fail to deliver their innovations from the lab to the market. We are on a mission to change that. My name is Chris Reichhelm, and I'm the founder and CEO of Deep Tech Leaders. Each week, we speak with some of the world's leading entrepreneurs, investors, corporates, and policymakers about what it takes to succeed on the lab to market journey. Join us. If you're an executive or entrepreneur building an advanced materials or chemicals company, and you're wondering how you're going to scale it, when you're going to scale it, what the obstacles and challenges of that part of the lab to market journey are going to look like, then you need to listen to this week's podcast. For your listening pleasure, I have Rob Davies. Rob is a process engineer by background, a senior manufacturing and operations leader who has served in very large corporates like Blue Circle, Lafarge, Holcim, Cabot Corporation, and is now a fully paid up member of the startup world, working with a company called 6K, a spin-out from MIT. 6K produces advanced materials for the additive manufacturing and battery worlds. I am hoping to have the kind of discussion with Rob where we really get into the guts of what being a manufacturing and operations leader is in a business like this. I know that Rob joined the company when they were about TRL 4.5, and they were questioning their own scaling journey. I'm really interested to hear how it's gone. I'm hoping that for your benefit, we can get an understanding of that journey, all of the different risks, the challenges, the obstacles they've had to overcome, and the cultural transformation they've had to go on. Because remember, this is a big cultural transformation too. So with all of that, I hope you enjoy the podcast. Let's get into it. Rob Davies, thank you for joining me.
You're welcome. I'm looking forward to this. Thank you, Chris.
I want to jump right into it. We've got the pleasure of your company today, and you bring with you a rich background in managing and scaling and bringing to market novel chemistry-based innovations. If you wouldn't mind for our listeners, when you joined 6K, where were they in their development?
So they'd achieved, if I describe this in TRL sort of concepts, they'd achieved the experimental proof of concept. They'd achieved that in the lab. They'd achieved technical validation by having some feedback from customers. And they were scaling to that 1 ton a month pilot scale, where you run at pilot scale, typically, 5 working days per week. And they were starting to contemplate, so what comes next? And they had the concept of having a 24/7 pilot operation. They were planning to build it nearby. But we then began to look at what the utility requirements of that pilot facility would look like. And we realized it would be a lot more cost effective to co-locate it with the full-scale production site. And so we've decided at 6K to locate both the 24/7 pilot facility and the full-scale production facility in Tennessee. And I think that's the pivot point that you need to begin to engage manufacturing leaders when you're starting to recognize, yes, we have a concept, yes, we're getting good customer feedback, and it's time to think about how we now build larger production capabilities. That was the time, I think, to engage people with the sort of experience that I bring to an organization.
So is that somewhere between a TRL 6 and 7 at the point when you started to get involved?
Yeah, at 5, 6, 7 is in that era. Yeah.
Yeah.
We certainly had the ability to produce a consistent product in the battery center of excellence. We'd already shipped samples to customers and got validation that, yes, the performance was, very interesting to these customers. And we got confirmation that they wanted to see larger scale samples. And so from a PPAP perspective, they were asking, when can we get the C sample and the D samples? And so that was the time then to think about transitioning to larger scale capacity.
That makes sense. From your experience, how often have you seen situations where technology is developed, material or chemistry is developed without much thinking for the manufacturability of it?
The people that develop the technology are, ingrained in the minutiae of developing the technology, and they're in love with, the nuances that come with the novel technology. You need a different mindset to think about. So how do we translate this now to actually building a production facility? How do we think about the provision of utilities? How do we think about organizing labor? How do we make it efficient? How do we make sure we have the ability for continuous improvement? And the technologists that have developed, the process that we're working with, typically haven't got that experience, typically are focused on the development of the technology and not so much on how to now scale it and build a manufacturing facility. And so they're complementary skills. But smart organizations recognize that you need to make this transition. And luckily enough at 6K, they recognized that and hired, competent people at the right time. But startups typically can fall in love with the technology and forget to think about, how do we now bring this to market and how do we scale this to meet customers' expectations? And, hard to put a metric behind how frequently that happens, but it does happen, particularly when you have the founders or the owners still involved in technology development.
Yes.
That's their speciality. And it takes a different skill set to think about building the commercial facing part of the organization and the manufacturing part of the organization.
It does. And so what can founders do? These same types of founders who are generally obsessed by the technology, and for good reasons too. What are some of the things they can do, in your view, to avoid the trap of creating something that ultimately they're going to struggle to commercialize and scale?
I think it's key to get good advisors around the founders, whether they are parts of the management team or whether they are, part of the board of directors or an advisory board of directors. I think it's important to have people that have seen technology growth and technology launch so that you can provide the right advice and provide the right steerage when needed so that you don't end up, in the narrow focus of being only mindful of what's the next step in the technology development. You have to step back and think about, where does this take us in terms of customer acceptance? How do we take our proposition to the market and gain acceptance at the commercial level? And then how do we support that by having the right manufacturing footprint at the right scale, at the right time, to complement, the growth commercially? And so the skill set commercially and from a manufacturing perspective really are quite different. And I think having good advisors around the founders is the place to get the right direction here.
Okay.
It's hard to think as a founder, when's the right time to bring a commercial leader on or a manufacturing leader. But I think the advisors can judge and provide good advice.
Yeah. How effective can engineers be early on in the process? Good scale up and engineering leaders, in your view?
I think it needs to come a little later. It needs to come at the point where you're starting to think about taking the novel technology into a manufacturing environment. That's the time when you need to be thinking about, how do we provide the utilities? How do we operate this? How how much automation do we apply for the first generation of unit? And do we wait for the second or the third generation before we introduce higher levels of automation? Because when you automate, you take the human touch out of it, and
Yes.
you have the risk here that maybe you haven't fully anticipated all of the automation scenarios that you need to. And so there's a balance here as to when you transition from a manual operation to an automated operation as well.
Yeah.
But I think it's at that point that it's the right time to bring engineers on board, people that have worked in a manufacturing environment, so that they can be thinking about those things.
Yes. Yes. Can you walk us through a little bit of 6K's journey from the pilot's stage when you met them to their first of a kind?
Yeah, so there were a couple of milestones, I would say, that we introduced. And maybe this speaks to how the technologists need to have a different set of skills at the table when you're starting to make this transition. When I first arrived, they were contemplating building a 24/7 pilot facility. And in terms of organizing the project, they had a program management mindset. And program management is typically about going through various stage gates. But when you're coming to build a facility, you do need to have construction skill sets and construction program management skill sets. And there are some tools out there, things like front-end engineering design and FEL1 through to FEL5 and FEL6. You need to approach the project recognizing that you've got to go from a concept design through to the basis of design, through to a set of engineering drawings that you can get quotes from vendors. You've got to have a document that you can describe the basis of design, and you've got to engage people that can build the building for you. So you need to engage architects. You need to engage process engineers that can do the plant layout. You need to engage control engineers so that you can actually control and operate the plant. And so I arrived at 6K as they were wrestling with this transition, and they were quite accustomed to managing technology development using a program management framework and using stage gates, but certainly weren't familiar with FEL frameworks and feed frameworks, and hadn't really thought through, are we going to do an EPC style project, or are we going to do a design build style project? And so luckily for me and luckily for the team, I arrived just at the time that we were able to have those discussions and make conscious choices about transitioning. And we actually chose to do a design build concept. Pace was important. We needed to manage the timeline of going from the A and the B samples to the C and the D samples in a way that matched the commercial growth and our ability to build contracts with customers. And so the pace became really important. And, EPC is typically where you do the engineering phase, you hit a pause button and review it, then you do the procurement phase, you have another review before you enter construction. But with design build, you've actually got the design work going on in parallel with the procurement work, in parallel with construction starting as well. And so the project that we have active here at 6K is a true design build project. Working backwards, we've broken ground and we are setting up the building plan. We're still actually procuring equipment and utilities and the framework of the building. And there are still some parts of the design that are still being worked on. And so it is a very parallel process, but it allows you to really concentrate the timeline of the project. And instead of what would have been maybe a 2.5 to a 3-year EPC style project, we're able to execute this in about 15 to 18 months. So a very significant time saving, but obviously the level of project risk changes. And maybe we can talk a little bit about project risk for a few seconds.
Before we do that,
You know,
can I ask one quick question in there before we talk about project risk? What was it that led you to believe that design build was the better direction than EPC?
the only new piece of equipment to the world was the plasma technology that we were introducing. All of the raw material preparation and the post-UniMelt process steps were all quite mature, and we could get process guarantees from vendors. And so there was relatively low risk with most of the flow sheet. And because we owned the technology, we understood the risk that came with that. And so for us, it was a natural step to take, that we can own the technology risk and the overall production risk, because we understood the risk that we had with our own technology. And we had then vendors provide us with process guarantees for the balance of the technology. So from a risk perspective, we had our eyes open in terms of where we had overall project risk. And then as we engaged with vendors, they were obviously, we started this project at the tail end of COVID. And so some supply chain issues were very long. Electrical equipment, for example, and switchgear had a really long lead time. And so we needed to place orders for some of that switchgear early in our overall project timeline. Otherwise, we wouldn't have been able to keep the project on track. And so a couple of issues influenced our choice here. We didn't have the luxury to do engineering and then do procurement, particularly because of the supply chain issues. But we also felt we owned the risk of our UniMelt plasma technology. And so it became a natural choice for us to take the design build approach.
I got it. You mentioned you wanted to discuss process risk a little bit.
Yeah, so I hinted a little bit about that a few minutes ago. When we have, let's say, a 6-step production process, each one of them introduces a degree of risk, because now you've got to match the process capabilities of one step with the following step. And you've got to make sure that the vendors are willing to sign up for the flow sheet that you've designed and the capability that you're providing. And from a project perspective, it's like a triangle. You've got risk to worry about, you've got schedule, and you've got cost. And so you can typically manage 2 of these quite comfortably, but it's really hard to manage all 3. And so as we thought about risk, we decided to de-risk the project with some tangible steps. We went out to market and found general contractors and architects that were accustomed to working with novel technology and were accustomed to working in a design build project environment. So we de-risked our project by taking those steps. Our UniMelt was new to the world, and we decided to launch the first production facility with our Gen 1, our first generation of UniMelt, as opposed to introducing a Gen 2 or a Gen 3, which was, not quite as mature in terms of its technical capability. So we de-risked the project by going with a smaller scale but proven technology. And we also de-risked the project by then picking partners to help us with the fabrication of some of the equipment and the provision of assembled components. And so we thought about, the overall project risk in a couple of different ways, both from a contracting perspective, from a partner perspective, and then from the generation of the technology that we were deploying. And so those were several key steps that we contemplated as we put the project together. And it all fitted quite neatly with a design build program, because it allowed us then to continue to refine some issues whilst we took care of some long lead time items. For example, ordering the electrical equipment. And, they originally were on lead times of 60 weeks. That's since changed. But when we started, that was an important timeline for us, and we wanted to de-risk that and place those orders early.
the capital requirements to pursue this line, this strategy, are they raised compared to EPC?
Yep, it certainly has the potential to have a higher project cost because, the value of EPC is you do competitive tendering, and you level the tenders and you create some leverage with the vendors to drive down some cost savings. We were successful, though, in driving some procurement savings during our design build project because we had the mindset that we would always have 2+1 vendors. We would always have 2 proven qualified vendors that we could, put against each other from a competitive perspective. And one vendor that was a developing vendor that maybe brought, a new technology or a cheaper technology or something that gave us a competitive advantage. And so we applied this 2+1 concept very consistently throughout all the procurement phases here and actually achieved some significant cost savings because we always had 2 companies that were qualified and viable. And we were able to leverage one against the other to get, good economies in terms of the procurement savings. So we didn't pay dearly, from a design build cost perspective. I think we feel really good about the cost of the project. For sure, had we had more time and were able to drive more procurement savings, we might have saved a little more. But the advantage is that we've now come to market a lot faster than had we gone through that longer process. And coming to market early was really important with this technology.
On the commercial journey, how successful has 6K been at managing those commercial expectations with potential partners and customers? And what is your view on how that's done best?
So in the battery material space, there are a couple of different categories that we've thought about. You have the OEMs, the large automotive car companies who have very heavy process. They have a lot of qualification criteria. They expect us to implement things like the IATF standard, where you have to have supply chain risk processes and quality management systems. And then you have the companies that produce things like domestic batteries. They have a lot less process. There's a lot less risk involved. And we categorized the domestic battery producers as go-fast customers, and then the large OEMs as the OEM category. And having 2 categories of customers allowed us to be able to come to market quickly with the go-fast customers and prove the concept and build a portfolio of supply contracts, whilst at the same time working with the larger OEMs that have more stringent qualification criteria and a lot more process to work through to secure a contract. The RFQs that you get from an automotive car company can run to hundreds of pages. We dealt with one the other day that was 600 pages long. The battery producers, they might give you a 2 or a 10-page RFQ. There's a very significant difference here in the rigor that these companies bring to commercial negotiations. And we've got a handful of contracts in place with the go-fast customers, people that are in the domestic battery sort of environment. And we're working through at least half a dozen RFQs now with, automotive OEMs. And it's a process. And, we've had to dedicate some people to just work the process to make sure that we are meeting the timelines and meeting the criteria that they set.
Are there lessons you've picked up on how best to manage this process?
I think people count for a lot here. Having the right skills in the team, I think, is critical. Having the right commercial mindset to make sure that you can win in the commercial environment and bring, the potential for revenue into the business. That's a real key to be able to scale your business. Because without commercial contracts, you don't have a book of business. The technology team also has to be agile. You've got to be able to, learn as you gain more experience and apply it and course correct and improve. And so there's a strong continuous improvement mindset that's needed in that technology team. And then the manufacturing team bring almost a different set of skills. They need to be able to build a facility. They need to be able to lay out the flow sheet. They need to be able to think about how are we going to operate the equipment? What sort of skills do we need? Are we going to automate this? Are we going to have, unskilled labor to be able to operate the plant? And a very different skill set to, trying to prove out the technology and figure out what's the next improvement we can make with the technology. And so I think the symphony, as you described it, needs many different sections. You've got to have people with skills in all three of those dimensions. And they need to complement each other and sign up to the mission and then be able to integrate their activities in a way that you've blended it to develop a coherent business plan.
We've worked with a number of clients who have chosen to work with third-party manufacturing groups in order to help them scale. And others, like yourselves, are taking this on themselves. Do you have a view as to when a group should go with a third party versus taking it in-house?
I personally think the in-house approach has a lot more ownership of the technology, ownership of the business plan, and ownership of the success of the enterprise. The development of the novel technology, I think, is clearly best owned in-house. You understand the nuances of the technology, you understand the dependencies of one piece of componentry with another piece of the components. And early investors are always looking for that deep understanding of what it is you're creating. But when you're developing a full-scale production site, you need then a different blend of skills. You need to be able to put the process steps together. You need to be able to design the layout, provide the utilities, make the right decision on automation. And that's where some good advice can be helpful. And at 6K, we were intentional about making sure that we could project manage this in-house, but we would outsource the engineering and the architecture and the control strategy. But we made sure that the project team had the knowledge about the technology and the experience to actually bring a technology to market. But we partnered with people that were comfortable with the design build philosophy and were comfortable with the pace. And sometimes, we don't have all of the answers, and the contractors typically have to be comfortable with some ambiguity. But had we gone down an EPC route, for sure we could have contracted somebody at a price to program manage this for us, but they wouldn't have the same ownership and the same passion to make sure that it succeeded. And we would have probably spent a lot more time focusing on project communication and project alignment, trying to make sure that all the parties had the same set of data and the same facts. And particularly when you get into large chemical projects, it's more typical that you have a dedicated program manager in the middle of all the contractors coordinating all the pieces. I'd like to think that the technology that we're building at 6K is modest in terms of its complexity, and we saw more value in leading it from an internal perspective, but just partnering with some capable contractors that could support us with the right skills when we needed it.
Yeah. You mentioned earlier about the journey that technology development teams need to go on in order to adapt to this phase of the lab to market journey when you start producing at scale. Can you talk a little bit about the evolution at 6K of that technology development team and the practices and the behaviors. Is it something that's been quite natural for them? Has it been a challenge in certain areas?
So the technology team has grown over time. The technology was a PhD thesis way back in 2014, and it got spun out. And the original organization was only a handful of people, and they were trying to explore, where does this technology have its best application? And so they went through a couple of years of discovery to try and understand, where can we best apply this unique process? Treating materials to 6,000 Kelvin is quite a unique chemical environment. It's the temperature of the sun, by the way, and figuring out what chemical reactions were best suited to this process did take some time. The technology leader, the CTO, had experience from a couple of other battery startups. And so he brought that unique knowledge about what it takes to be successful at the current phase and what it would take to be successful at the next phase of growth. And so he was very instrumental in guiding that transition. And very successful at it.
That's super helpful. Rob, if you don't mind me asking, how early were they working with process engineers in the technology team?
We had some process engineers on board quite early because they were trying to figure out, how to optimize process conditions.
Mm-hmm.
But in the battery materials space, they probably came in the second wave of hiring as to when we brought chemical engineers on board, so that they could operate the equipment and fine-tune the equipment and then optimize, the process conditions so that we could produce consistent products on a consistent basis.
Yeah. Financing for businesses like 6K, not necessarily 6K, but businesses like 6K has been a challenge, particularly over the last couple of years. Do you have any views? I mean, you guys are crossing the chasm right now of scaling these pilots by the design build stage, and you've successfully raised, as I understand it, too. What advice or what lessons have you learned about this that you might pass on to others?
I think the organization needs to think about the level of funding you need for the next phase of growth and maybe even the next two phases of growth. You can't just be satisfied with having funds for the current phase. Fundraising does take quite a time, and it's all about building relationships and building a level of understanding at the investor that they completely understand what you're trying to achieve today and what you're going to try and achieve in the next phase. So I think it's key to be thinking about your fundraising for the next one or two phases of your growth. And certainly before you commit to large investments, like building a day shift pilot facility or building a 24/7 pilot facility, you've got to make sure that you have the money in hand and the cash flow mapped out for the period that it will take to bring that operation into full-scale production. So you have to have some foresight. You have to be able to build a cash flow that transitions several stages of growth. And you also have to be, in parallel, building relationships that are at different scales of investment. Early investors are typically looking for proof of concept. They're looking for the ability to bring a new technology to market. But then when you're going from a proof of concept to now trying to deliver samples to customers, the level of investment you need is typically higher, and the level of understanding of the investors is a little different. They need to be mindful that you're bringing a concept to market, and it's not just proving a concept, you're now trying to commercialize a concept. One thing I would say, though, that in the US, there are many government programs that allow you to support growth such as this. And we've been particularly successful because we had one individual dedicated to seeking out government programs. we've probably raised over $150 million over the last few years from various government programs. And the project that I'm currently executing, we actually have a grant of $50 million from the Department of Energy, which is part of the Biden Inflation Reduction Act. So the government is usually a rich source of funding, provided you can tap into the right groups and get the right degree of support here at various phases of your growth.
Absolutely. Well, the U.S. is blessed to have that program. Long may it continue. We'll see how long it goes on for. But it's a great program, and I know they've been trying to attract companies from this side of the pond as well. What about the evolution of operations as a function within this type of company? Can you talk a little bit about that, about that role of operations leader, where it typically starts and when it might engage and how it evolves over time?
Well, that's a really good question. It does change with time. A few minutes ago, we talked about the nature of the technology evolution and how you go from having a couple of engineers just proving a concept to looking at different markets to then supporting that with product and process development. It would certainly be too early whilst you're still in the proof of concept phase to be thinking about operations. You need to be thinking ahead that at some point you're going to have to commercialize this, but you don't need the team in place when you're still proving the concept out. But when you're making that transition from, all right, we're now going from a lab scale concept to a pilot scale concept, and soon we're going to go to a 24/7 style of concept, style of pilot plant. That's about the time you need to think about how are we really going to operationalize this? How are we going to staff this? What's the degree of automation? How are we going to move materials through this plant? How are we going to provide the utilities? I think that's the time that you need, operational capability. And obviously, you don't need to hire a whole team in one instant here, but having one or two key leaders in place that understand how to make this transition and then know when to hire the right complementary skills and when to add, new experiences and new skills to the team. That initial operations leader should have the right experience to make that judgment so that you can, not build too big of an organization too quickly and burn through a lot of cash, but build it quickly enough that you are a step or two ahead of where the projects will need to be in terms of executing, in terms of pouring concrete, putting steel in the ground, and actually installing equipment. So that's, I think, the transition point when you're going from the sort of the lab scale or the day shift environment to a 24/7 environment. That's when you need a different set of skills. But the operations team needs to be multi-dimensional in terms of skills. They obviously need to know what good looks like, so that you can build a reliable plant and a plant that's easy to operate. You have to remember you're building this operations team alongside a technology team. And so the technology team is usually very agile about taking new data and adapting and improving. Sometimes that can be a little frustrating for the operations team. They want well-defined scopes, well-defined basis of design so that they can execute efficiently. And so the operations team need a degree of agility as well here, because it's typically a fast-paced organization, and you have to be willing to wear multiple hats at any time and tackle multiple priorities because they don't come in a linear fashion. And because of that, I think that the individuals need a degree of resilience. They need to be able to, handle competing priorities, changing dynamics, changing scopes. But certainly, if you get the right skills in place and they can be complementary to the technology team, then you could have a really successful project.
Are the types
And
of
also,
skills,
you need it.
sorry for interrupting.
Go ahead.
Are the types of
Yeah.
skills you need when you're building your first prototypes, the types of operation skills you need then, are they the same ones you need when you are managing your operation, for TRL, sake, you're TRL9, you're in the market, you're producing at commercial scale. Are those the same types of operations executives or team members you need, or are they different?
You could be fortunate enough to have some of the senior people that have experience with the development environment, as well as the scaling environment, as well as the production environment. So, if you can find somebody that could work through that transition, then you'll have hit a home run. But you're right, that they're subtly different. And certainly when you get into the production environment, it's about reliability, it's about predictability, it's about consistency, and you need some discipline. And that process discipline, it doesn't always appear when you're in that development phase where new ideas are emerging and new process steps are being developed, and you need an agility. The agility that comes with process development is a little different to the discipline that's needed to running, production capability on a 24/7 basis. You might be lucky to find individuals that can manage both of those dynamics, but they are subtly different. And that's why you have to be willing to allow the team to evolve and bring the right skills into the organization at the right time. For the facility that we're building in Tennessee, we did take the philosophy that we would hire the management team early so that they could be involved in the process design and then own it as we brought it into production. And so we've hired a small leadership team, and they'd be heavily involved with process design. But we all recognize when we get into full-scale production, the complementary skills that we'll have to bring on board alongside us will be more about consistency and quality management and, having financial controls to make sure that the OPEX and the CAPEX are to plan. That those skill sets are more stability focused and discipline focused compared to the sort of the entrepreneurial mindset that you have when you're designing something and you need to adapt because you learn something new day to day.
Yeah. Let me ask, I've asked this question a couple times already, but I want to ask it in a slightly different way, only because I want to know. The early technology development process, is there any way that can be improved upon by considering operational issues at an early stage? For example, manufacturability or supply chain issues or, I don't know, whatever. I mean, regulatory issues as well. And there could be lots of others. But in your view, is it get through the technology development, let's see what you got, and then we'll worry about some of these operational issues once you've gotten past a certain stage?
Well, I think it's context specific. If you were developing an assembly plant where you were putting widgets together to develop components or sub-assemblies for something, you certainly need a high degree of predictability, and you certainly need to spend a lot of time on the manufacturing concepts before you put this whole plant together. I think a chemical process is a little more forgiving. At 6K, we had the foresight to actually install full-scale Unimount production units in the Battery Center of Excellence. And so we had operating data as to what a full-scale Unimount needs from a control perspective and what it needs from a utility perspective and what it produces from an output perspective. And so in our situation, we didn't need to be thinking too much about the overall manufacturing capability whilst we were still developing the technology, because we were developing at a full-scale Generation 1 unit.
How early was that unit in place? How early was that unit in place? Like how many years into the journey?
Maybe three years into the overall journey. Yeah. They had previous generations of it, but we built the Battery Center of Excellence with 4 full-scale Unimelts. And we ran them on campaign basis, not on full-time basis, but on a campaign basis, we understood, the process parameters and the needs of the process unit. Now, when we began to decide, all right, now it's time for us to pivot from, a lab environment or a day shift pilot environment to a 24/7 environment, that was the time we began to consider. So how do we marry the Unimelt up with the raw material preparation steps and with the post-treatment steps? For us, that was the right time to be thinking about the manufacturing scale-up process. Now, it's not a case where the same solution applies to all situations. Had we not had the ability to run a full-scale Unimelt, we might have spent a lot more time worrying about the scale-up of the overall plant. And maybe I should also underline here, there's a lot of effort put into designing the Unimelt so that it was a full-scale Unimelt. So, there was development work that went along to think about the overall operation of a full-scale Unimelt whilst they were developing, the process and the product technology. But from an integration of this unit into a full-scale manufacturing plant, for us, it was a separate step. And it really happened when some new employees were brought on board, people like myself, who were brought on board to think about the scale-up and to the development of the manufacturing footprint. And so the technology organization, took the technology to a TRL 4, TRL 5, but then as we needed to transition to 24/7 pilot operation and then full-scale operation, we intentionally brought a different set of people on board and a different set of skills.
That makes sense. And that makes sense. And that, rightly or wrongly, that aligns with what I've seen in the past, and I guess aligns with my beliefs to an extent, that if they're at a TRL 4-5 and they've got a functioning pilot that is broadly at commercial scale, it may not be, it's not going to be 24/7, but they've got a functioning pilot from which they can learn. That's going to further de-risk the process going forward, because there are a whole bunch of lessons they've already learned about it. And it's going to make the ultimate journey to 24/7 that much easier. There's still risk, but you're not questioning the fundamental scalability of it at that point. The risks are different.
Yep. And so this goes back to that conversation we had a little while ago about project risk.
Yeah.
We bought, most of the production equipment from proven vendors with process guarantees, and we managed the risk because the vendors were taking the process risk. The only place we brought risk was with our new technology. And to the point you just made, we'd actually operated this at full-scale production. We have 4 different units in the battery center.
Wow.
And so we felt we owned that risk and understood it and knew what we were getting into. And so it gave us some confidence to say, all right, now is the right time to scale to a 24/7 operation.
That's great. That's great. That's a well-managed business. I have very much enjoyed our conversation today. Thank you so much for joining me.
I've loved it, and it was great to share our story and our experience, and hopefully there was some insights in there for others to benefit from.
I'm sure there will be. Thank you again.
You've been listening to the Lab to Market Leadership Podcast, brought to you by Deep Tech Leaders. This podcast has been produced by Beauxhaus. You can find out more about us on LinkedIn, Spotify, Apple, or wherever you get your podcasts.